didn't expect, or I don't think any of y'all expected we're going to be going to school today too. Obviously, I was already introduced. My name's Noah France. One of my classes that I do with college is a speech class, and obviously that means I have to give speeches and talk in public and make eye contact with people, which is a thing that I have to learn how to do still. So today we're going to talk about black holes, and I hope that not only does this teach you something new, but it'll also kind of help you understand that he makes some pretty cool stuff. And this just happens to be one of those cool things, so I hope you really appreciate it. So I kind of want to start with an illustration. So close your eyes, do whatever you want, but imagine you're floating in space. Stars glitter like shattered granite, planets are suspended in the distance, and space dust cascades across the dark. Suddenly, you encounter a patch of solid black. There's no light, surrounded by nothingness. Before you know it, you're being pulled forward by an inexplicably powerful force. Time begins to feel like it's moving slower, and now you're falling infinitely as you're stretched cell by cell, atom by atom into a piece of hot plasma, which does not sound fun. All right, so what just happened? If you were paying attention, well, that was a black hole you were just sucked into. And that's pretty much exactly what would happen if, in theory, you were able to stay alive long enough for you to figure out what's happening around you. So black holes are one of the most enigmatic and complex subjects in astrophysics today. We still don't know a ton about them. Scientists are still trying to answer questions about this phenomenon. Many people often don't know about how black holes work, or where they come from, or even like, what are they? Like, how do they work? And to give a little bit of background, in my freshman year of high school, I was asked to, in my debate class in high school, to choose a topic that interested me, to make a presentation on it. I had to persuade them to prove a point. And I stumbled upon the topic of black holes. And I was like, well, all right, seems interesting. So I looked into it, and I realized that my perspective on like what they were and how they worked was kind of off. And my debate ended up being about proving that black holes didn't suck like a vacuum. Which I know sounds really silly, but I gave it lots of backup and evidence. I was really proud of that. And the research actually seemed fun, and it fascinated me for once in my life. And I say that for once in my life because when does research for a school project ever fascinate you? And since then I've wanted that information to be shared more in depth, and now I get that chance to do it. So today I'd like to talk about how black holes are formed, how they work, and the science behind it all. So first I'd like to talk about what a black hole is. Essentially, a black hole is an incredibly dense amount of matter, usually 3 times the mass of the sun. So think about it, enough stuff, 3 times the mass of the sun. And it's very densely packed into a very, very small packet called a singularity. A couple things to know about that. Singularity has its own gravitational pull. And also black holes aren't really black, they're actually invisible. So you can think about the background of space as invisible. So that's why we call them black holes. But they're really just invisible. The only reason we're able to see them is because we can see the effects of them around. Also says that Einstein's theory of gravity, which says that the escape velocity for a black hole is greater than the speed of light, which basically just means that light, even light, can't escape the black hole, which proves also that it's invisible. Because in order for you to see something, you have to see the light bouncing off of that object and coming back into your eyes. But light doesn't hit black holes, it just gets sucked into it. So that's why they're invisible. And lastly, like I said before, scientists observe black holes by the effects that they have on things around them. Usually by noticing pieces of stars become basically slawed off and then sucked into a space, or you'll see pieces of debris moving towards a central point. The next thing you should know is that a black hole has an invisible ring called an event horizon. This is kind of like, you can think of it like the equator. It's not really there, but it's something that we use to measure. The event horizon is a marking that marks the pole, or the boundary for the black hole. Basically, once you pass the event horizon, any particle, including light, cannot escape the gravity of the singularity. Before that, you can observe it and you can be as close to it as you want, but as soon as you go over to the event horizon, you are moving towards the center, towards the singularity. So that kind of explains what they are. Basically, they're just super small pieces of matter with very, very, very large gravitational pulls. So that covers that, but how do they form? Black holes usually form from dying stars. Stars have a couple of phases that they reach, but the very last one is called the supernova phase. What happens during the supernova phase is that the mass of the star becomes too much for it to handle and it collapses on itself. What happens is all of that matter starts moving in on itself, and once the mass crosses its own event horizon, then it begins to create, time begins to change from the perspective of the observer, meaning that it actually slows down enough that it actually freezes, basically. It'll stop the collapsing object in time. So instead of it being completely destroyed, the matter is constantly moving in on itself, essentially getting crushed smaller and smaller and smaller until you can barely see it. Or it's microscopic, basically. You can kind of think of it like, if you have got a bag of chips, right? I don't know which of your type of chips, but mine's Lay's. Say if you got a bag of Lay's, and you're holding it in your hands, and you crush it, and now you've got crushed up chips, which nobody likes to eat, and then you crush it again, and then you crush it again and again and again, until you basically got a little teeny tiny pile of chips. It's still the same amount of chips, but now it's super small, and it'll still have the same effect of gravity too. It's kind of like that joke talking about a pound of feathers. It's still a pound of feathers no matter what it's made of. It's still just as heavy. And so you can basically think of like, I don't know how many bags of chips that would be, but enough bags of chips to encompass the mass of 3 times the sun. So that's a lot of chips, all down into this tiny little space. And that fascinates me, that's amazing. And basically, once that happens, and that object starts collapsing in on itself, the force of gravity becomes strong enough for it to start sucking in even more matter, and when it does that, that's how the black hole grows and becomes bigger. Now, there's a thing in theory in astrophysics that's called Hawking radiation, and that's what actually causes the black hole to lose mass as well. The way it works is every piece of matter that the black hole takes in, it becomes part of the singularity, and because it becomes part of the singularity, it gets more mass, and therefore it becomes stronger. But at the same time, it starts radiating off anything that it loses. And this is what causes black holes to be varying sizes. Some of them are like 12 times the mass of the star, or 12 times the mass of the sun, I'm sorry. And then some of them are just strong enough to sustain themselves. In fact, that's actually something that scientists have been doing today. They have a collider somewhere in California, I think, that they're trying to create small black holes. The thing with that is, you have to have just the right amount of matter to collapse in on itself for it to happen. And they're colliding tiny particles together, so they're creating very, very small black holes that will last like a nanosecond, and they're gone. And so that kind of goes back to the theory that all of the matter that gets taken into a black hole eventually get radiated off over a very small amount of time, but when it happens to be that it's only 2 particles put together, it goes away pretty quickly. I think that basically covers everything. That's basically all the information I have on black holes. And for it to be better understood, you could probably ask an expert. I am definitely not an expert. But as we come to a close, I'd like to thank you all for coming to learn more about these black holes. As we covered, black holes are large amounts of mass compressed into a very small space. They have their own gravitational pull, so strong that not even light can escape it, which still boggles my mind. And they have a ring called the event horizon that marks the beginning of this gravity. And they're formed from dying stars, usually. Black holes are amazing phenomena, and as such, I hope that you are all just as intrigued and as amazed as I was about researching this topic. Thank you all so much for listening.
Amen. Thank you, Noah.